morning, good afternoon, good evening. I'm Gregory Foden, and I'm the FX infrastructure lead here at Citigroup. I'd like to talk to you today about how event-driven architecture fits into our FX trading ecosystem here at Citigroup, in particular in the FX trading space where EDA is particularly relevant. So as part of this short presentation, you will discover how certain messaging aspects that have been prevalent in financial markets for several decades have been the building blocks for the adoption of an event-driven architecture by our FX business. So I've been working in financial markets technology for 17 years now, having started in the market data and messaging space, an area I've been focused on and off for large financial institutions in various different capacities. And although my role as FX infrastructure lead has a number of architectural aspects to it, my role still involves a lot of operational duties. I work closely with our FX support organization, in particular around messaging middleware, as well as around other application infrastructure considerations. So you might notice a certain operational focus on the slides in this presentation. So our team here at Citigroup is called FX Infrastructure. So we're a small team of 7 engineers distributed globally. And as a team, we focus on quite a wide range of technical areas across FX applications due to having different technical backgrounds. We work closely with our FX application teams as well as infrastructure partners to have a consistent and informed approach to considerations such as EDA. My focus in my career has been primarily messaging middleware, but as this is a technology that interfaces with a wide array of components on both the application infrastructure side, I'm quite close to most of these other technical areas we've got listed here. For example, it's not possible to focus on performance tuning of your inter-application flows without checking that the configuration and design of your messaging middleware layer is optimal. Similarly, whenever you're looking at more operational initiatives such as data center migrations, the application infrastructure and middleware components are often at the core of your approach. So before we delve into any technical details, the purpose of these next couple of slides is to present how FX markets are structured and what is unique about FX as a business. And these unique characteristics then shape the technical questions we need to address whenever looking at our application infrastructure. So the FX market or markets can be described as an over-the-counter marketplace that determines the exchange rate between two currencies. So that's obviously a very straightforward and simple definition, but the key takeaway from that statement is the over-the-counter element. So unlike a number of other financial markets, this is a market that is not centralized in any real way. So any two participants of the FX markets can trade with each other. They don't need to go through a certain exchange to settle that trade. And it also happens to be the largest financial market in nominal terms. So the Bank of International Settlements has measured 7.5 trillion dollars traded in a single day in April 2022. It's also, as you'd expect, a very global market with a network of globally distributed financial centers and with a number of different traded instruments. So standard spot as well as forwards, futures, swaps, and you can also include options, of course. And regarding the global element of the global nature of the FX market, it's a market that opens when New Zealand traders come online on a Sunday night. So I say Sunday night for us in London, but obviously it's 7 a.m. in Sydney. So the reason why I mentioned Sydney, we tend to announce that time in the Australian Eastern Standard Time Zone due to the trading session being named after the larger trading hub of Sydney rather than Wellington, but it actually starts when New Zealand traders come online. And the market closes when New York trading ends on Friday, 5 p.m., which is 10 p.m. for us in London. And this is, like many other markets, a market that's gone through a lot of electronification. So we have more electronic trading going on than voice trading these days. So within the FXE trading space, it is worth mentioning ECNs, i.e. electronic communication networks. So ECNs can be visualized these days as a set of servers located in a strategically situated data center, usually owned by a third party specialized in co-location. So this is obviously very different to the traditional image of what constitutes an exchange as traditionally conveyed in film and in media, where you would see human traders shouting over the trading pit in the open outcry system. So bar a few exceptions, that form of trading no longer really exists. And many of the data centers where ECNs choose to place their servers are located just outside traditional financial centers. So in the case of New York City, a number of these colo sites are in New Jersey. And similarly, in the case of London, some of these sites are in the home counties just outside the Greater London area. So what does the ECN provide as a service? So the core component of the ECN is its matching engine. So its matching engine, which is obviously because it runs on a server, it is essentially a server processor, or rather a set of server processes that pair up buy and sell orders currently present in the exchange. And if you were to look at the FX market or the FX trading market more specifically, you will see a number of different market participants of varying sizes, and some of these are market makers or liquidity providers. So Citigroup falls within that category. So what is the role of the market maker? They provide liquidity, set prices, absorb risk, facilitate trading, and manage volatility. So by providing liquidity, what I mean by that is that an investor who wishes to submit a trade into, say, an ECN, they will find that they can easily find a market maker on the other side of that trade that allows them to settle that trade very quickly. Whereas without the presence of the market maker, the investor would obviously have to wait for another investor to come along with the opposite trade and for the trade to be settled between the two investors. So that's effectively the role of the market maker. So in the same way as ECNs have cabinets and servers in strategically located data centers, market participants like market makers will also have a similar server presence. And the obvious motivation to place those servers in the same data center is to send, receive orders and quotes with the ECN, but also with other market participants, such as a customer connected to us via the fixed protocol, as fast as possible with the lowest latency. So I won't delve into the components on this diagram I've drawn, because that would kind of fall out of the scope of this presentation, but we can categorize the flows between these components into various categories. So I've listed 5 categories that are somewhat subjective, obviously. They're my own interpretation, but you could categorize them into external flows, flows within the local area network, flows between these colo sites and the nearest campus site, as well as flows between the campus sites themselves. So by campus, I mean a site, a data center owned by the actual financial organization, rather than the colo site, which tends to be owned by a third party. The WAN distribution between our colos, so what I described as cross FX, as well as distribution within the local area network to UI processes. And all of these flows will have performance expectations. We'll have performance expectations for these flows, in particular around the latency. However, even though we may say that all of these or a number of these are latency sensitive, sometimes that can mean different things. So for a local area network flow, latency sensitivity may mean that we're aiming for latency in the double digit microsecond ballpark, and when we're talking about distribution across the WAN, we're looking more at double digit milliseconds, simply because of the distances between these sites and obviously the speed of light. So kind of broadening our view now at FX specific requirements, we've already spoken about that need to distribute data globally between different sites where we're present, but also the local area network distribution. And we mentioned that latency is obviously key for us, but more importantly than low latency, that's simply low latency, we also care a lot about the predictability of that latency. And you'll see in a later slide that we do handle large volumes within our event-driven architecture, but more importantly, one of the main technical challenge of those volumes is how they can vary widely during the week while the markets are open. So around a market announcement, we can have volumes increasing tenfold, 20-fold, maybe even higher. So when do those bursts happen? You can think of an announcement from the Fed, from the Federal Reserve, the announcement from even a politician, a political leader, or even a scheduled market announcement such as non-farm payroll. Stability is an interesting requirement for us because we don't have any intra-week maintenance. So we can't shut down our systems on a Wednesday evening in order to perform maintenance. There is no downtime because of the markets always being open. Platform manageability is important. Support of multiple APIs is also key because we need an EDA that can support both our UI clients as well as server processes, and also the ability to integrate across a wide array of different applications. So our FX eTrading applications interface with other FX front office systems as well as post-trade systems. So where does event-driven architecture fit in the FX market, and why would a concept like EDA be relevant to us? Well, actually, it's particularly relevant as many concepts behind EDA have been present in our space for some time. So if I start with the types of messages you might see in a front office FX system, I've listed a number of them here. Um, and a few of these message types, although not all, have characteristics in common. So I've listed market data updates, quotes, orders, risk position updates, but I could also delve into things like forward curves, volatility curves. These are all messages which allow our pricing systems to operate as well as our trading systems. But a number of these message types have these characteristics. So they will continuously stream throughout the week. So that's obviously reflective of the fact that FX market is always open. They will burst around a market announcement. We also have quite a lot of high fan out requirements. So one publisher sending to tens or hundreds of different consumers. And also the typical size of these messages is quite small. So you're looking at hundreds of bytes and usually staying around the 1 kilobyte ballpark. So some of you may pick up on the fact that these sizes are below the maximum segment size, the MSS, that specifies the largest amount of data that a TCP payload can support. So obviously that does have technical ramifications that we don't need to delve in here at this moment. So you'll find the following requirements for a number of our flows. So we need our flows to be distributed. So I need to be able to tune into a given topic, for example, related to a market data feed, and receive updates on that topic, regardless of where in my network that publisher is located. I need my flows to be asynchronous. So I will usually want to receive messages as soon as the message is available and my application is ready, rather than repeated polling, request reply. And scalability. So I may have one consumer listening to that market data update that I mentioned, just as I may have hundreds of consumers. And my EDA platform must perform in exactly the same way. I can't have a system that operates that performs completely differently depending on the number of consumers that are present. And latency matters, as I want to react to these events in as close to real time as possible, so that my pricing systems reflect the state of the market. And fault tolerance is usually key to us. So I can have two or more publishers in an active standby model. And my consumers usually don't care if publisher one or publisher two is sending. Similarly, I can have multiple independent consumers backing each other up. So that also reflects the decoupled nature of our EDA communication. So these are 4 different types of messaging patterns which are very common in our estate, and they're all supported on our EDA platform. However, it's the pub/sub model which, in my view, underpins event-driven architecture the most, as it allows an event producer to inform a large number of consumers in real time of an event such as a market data or related pricing event having occurred. So you can think of the pub/sub pattern as akin to someone tuning into a radio station or a TV channel. So each listener is independent of each other, and the broadcaster doesn't change its behavior depending on whether there is 1 or 1,000 listeners out there. And it's a model that has been prevalent in e-trading environments for 2 to 3 decades now, for the distribution of real-time prices and other similar messages. So in a way, the adoption of an event-driven architecture is an evolution, a natural evolution of that pattern. So now coming to our technical choice, our technology choice when it came to building an event-driven architecture. So we opted, so CityFX opted for Solace back in 2013, and it's been our strategic messaging middleware and data distribution platform since then, and it's used across all FX business areas, mainly for that purpose of integrating across those systems that I mentioned earlier. And obviously you can see here there's a steady adoption of the technology over time. Now, here's our FX Solis estate summarized in numbers. So we have 31 hardware brokers distributed across 12 locations. So now's a good time probably to mention that Solis have three flavors of brokers. So there's the hardware broker, or what we sometimes call appliance, the software broker, and the Solis cloud offering, which is based in the public cloud. So as a business, we operate predominantly with the hardware broker, which was obviously the original flavor of the Solis broker, but we have kind of stuck to that hardware broker due to that need for latency predictability and general performance predictability. So those 31 brokers that are distributed across 12 locations, as you can see, they handle huge volumes of data every day. So we've measured about 30 billion messages just for our FX business in a single day. So that's a typical day, not a day around any specific market announcement. So if we now take a step down in our technology stack and look at one key aspect of our infrastructure, that would probably be the wide area network that links up four key trading hubs. And it will also kind of explain why EDA, why adopting Solis was so key in our technology strategy. So the FX business own dedicated trading links, so dedicated wide area network links between these four sites that I've listed here on this map. And when acquiring those trading links, they obviously would have had several considerations such as base latency, latency jitter, predictability, stability, redundancy, and bandwidth, as you'd expect. So this dedicated FX topology there that you can now see in the center of this diagram integrates into a wider network topology, which includes, so you can see the colo sites, that the rectangles, they're connected to a nearby campus site, which effectively is part of the corporate network. And like any other corporate network, these campus sites are interconnected. So when you've obviously invested in your WAN topology so much, how do you achieve return on investment? It probably goes without saying you're not going to want to just put any technology on top of your WAN network. There's no point of having cutting edge WAN link if you're going to put a transport layer which is not fit for purpose. So we opted for building a Solis event mesh using multi-node routing and VPN bridges laid on top of our WAN topology. So multi-node routing is defined at the broker, or as we call it, appliance level. VPN bridges tend to be defined at the individual VPN level. So VPN, just as a recap, is a logical container within your broker, within your appliance, that segregates all your application flows from those in a different VPN, unless you obviously configure a VPN bridge between the two. So although we use multi-node routing predominantly for global distribution of our direct messaging flows, so those are the high volume, low latency flows, and VPN bridges for our guaranteed messaging flows, we do sometimes opt for VPN bridges where we want finer control over our bridging, as the scope of that bridge is VPN specific. So we're able to have a single set of TCP connections for that single set of VPN bridges. So coming back now, just from a conceptual perspective, if we return to our WAN topology and how we want to layer something on top of that, which leverages our WAN investment, our investment in our WAN topology, this is effectively how we kind of picture this. We took all of our key sites and placed Solis brokers there and interconnected them using what we call CSPF neighbor connections, which allow multi-node routing, as well as interconnecting them using VPN bridges. So what has this provided us from an operational perspective? So just one key feature that I think is quite interesting is how placing Solis on top of our WAN topology has allowed us to leverage the TCP connection stats from our cross WAN links to health check our whole WAN network. So we monitor our WAN links in real time and look at certain metrics there that you can see: round trip time, number of retransmissions. And what that's allowed us to have is real-time WAN monitoring with detailed statistics straight out the box. So with minimal design and consideration, really. These metrics are readily available to anyone who wants to query the admin API, the SEMP API exposed by the Solis brokers. Equally, you may be using a monitoring solution that already has a plugin that allows you to connect into those metrics. And this has really been quite a game changer for us, in the sense that previously our support organization may have reached out to, so app support organization that is, would have reached out to our network support organization with vague complaints around application delays, poor customer user experience. And now what they have at their disposal is TCP level details around what has happened within the wide area network. So they can approach a network engineer and say, here's the TCP connection that I want you to look at. I suspect that there was a disconnection an hour ago, or I think there's a degraded WAN link there. So it's really made that interaction between the different support teams a lot more functional, and allow for a really good collaboration, and also ensuring that resources are used optimally within those organizations. So after more than 10 years of using Solis and having an event-driven architecture here within CityFX, what's been our experience? So we've seen improved stability. We've seen in-depth monitoring and capacity analysis, so as shown in that previous slide. Supportability and manageability of the estates has improved. We're now able to support numerous messaging paradigms where we would have had multiple different messaging middleware solutions. So we would have probably had one solution for our guaranteed flows, the flows that need persistent messaging, and we would have had a different messaging middleware solution for the low latency, high volume flows. And now, obviously, we're able to support all of those flows on a single platform. Scalability has been a great experience as well, in the sense that it's been, from our experience on the application side, upgrading appliances or relying on our fantastic CTI Solis team here at City. They've been able to upgrade our appliances in a way that is completely seamless to us on the application side. Adding brokers, i.e. horizontal scaling, has been a very straightforward and seamless experience as well. So all round, that ability to maintain our estate has really improved. So what are we looking at in the next few years? This is our roadmap when it comes to Solis. So we just completed a Solis Cloud proof of concept with the Solis team over here at City. We've explored a hybrid deployment model where we interconnect on-premise hardware brokers with cloud-based brokers in the public cloud. We're looking to expand our use of software brokers, in particular in the dev and UAT environments, continuing to migrate off legacy data distribution offerings. Also looking to continue upgrading horizontally and vertically our Solis estate, looking to enhance and continue leveraging that monitoring of cross-WAN connections. We also want to migrate to newer versions of products such as PubSub Plus Cache, which is the last value cache offering from Solis. And our application development teams have shown a lot of interest around some newer features that Solis offer, such as partition queues and message replay, that we aren't really using extensively as things stand, but probably more so in the future. So the next few slides are just disclaimer slides that I have to include. But after those slides, I'd just like to thank you for listening to this presentation. I hope you found this insight into event-driven architecture as it's used within an FX business interesting. And thank you.